Hi friends, don't forget to subscribe to my channel if you haven't done so. So let's talk about what's going on inside the hood. That example we just ran about the histogram ratings from movie ratings data. Good thing to understand here what is happening exactly under the hood, and not exactly for academic reasons, but also because you also want to make sure that you are structuring your Spark scripts in such a way that will perform in an optimal manner, and need to have some idea what's going on underneath the hood can actually help us do that. And as we move into more complicated examples, we will find out more. We will see how we can apply this knowledge. Now let's take a look at the example of the ratings counter. So in our previous example, what exactly happened when we called the function count by value in our RDD? It was kind of last step in our script. That was an action on our RDD which caused the Spark to go back and actually call an execution plan for actually how to get the results we asked for. So what happens there? Well, it keeps in track of all the chains of functions we did in the RDDs, like how they connect to each other, like text file, map, and count by value. Based on that information, it constructs an directed acyclic graph. In this case, it might be a very simple one. Looks a little bit of like this. Basically, we start with a text file command that imports a bunch of raw data into an RDD. With a map to an RDD, we can pass out that information which we actually care about, which is actually the rating themselves. And then finally we call the count by value to action to total up the different numbers of each rating type. So basically that is the execution plan which we discussed and we wrote in the previous video. And in the diagram you can see here a little representation of how that gets manifested. In this example, five different lines of ratings data is here, and these gets piped down, and where they are mapped to just extract the actual ratings itself, and eventually we add them all together. Now the important thing to realize here is that with map there is one-to-one relationship, let's say, between each input and each output row of the RDDs. Basically, we can actually keep all things partitioned in this. Basically, we can keep things partitioned in the same manner, right? As these are all a bunch of parallel lines, which is just taking a bunch of data and then transform again. Now all this happened very easily in a distributed manner. But what happens when we call the count by value? Well, we might have to shuffle things around here. Okay, so this is where the things gets little complicated. Now in this we have couple of rows different here, and then combined together in the final count by value stage. And so these two ones have to be moved around to this final result too. So this is what we call a shuffle operation. in Spark, and that can actually cause Spark to push a bunch of data around in your cluster, and that can be very expensive operation. So a lot of times when you are optimizing the Spark jobs, you need to be thinking about how can I minimize the shuffle operations, and how can I make sure the things remain parallel, basically parallelizable when I'm mapping things. So once it has that execution plan, that's what basically Spark does. It looks pretty much like a couple of places where you need to shuffle the data and use itself to delineate the stages. Okay, so what happens is then Spark breaks this job into say 2 stages, where the first stage is at text file and where we read in the data and then map it just to extract the data we need. That can be run all together in parallel, okay, as one stage. But then on this count by value command, things needs to get shuffled, and that needs to be handled as a second stage. Okay, so these stages are created based on tons of processing that can be done in parallel manner without shuffling, that is without shuffling things around again. And when you actually run the Spark job, it will give you the output if it's been actually distributed, indications of what stage it's running currently, and that's what it's talking about. And then once we have our stages, it will split those stages into tasks. So that's where the things actually gets distributed. Now notice that we have these sort of parallel lines of transformations going on. Maybe it will break up these 2 lines on one node of your cluster, and then the next 2 lines on the another node of your cluster, and the last line on another node of your cluster. So the task just break up into parallel, like parallelizable tasks, because like I'm lack of a better word here, into discrete pieces that can be processed individually and then run in parallel. Okay, makes sense to you? Don't forget to mention those concerns into the comments of this YouTube video, and don't forget to subscribe. So basically, in a nutshell, we started with an execution plan, and then the execution plan was broken into stages based on things that can be processed in parallel fashion, basically that don't have a shuffle involved. And then stages gets broken up into tasks that are distributed to individual nodes on your cluster. So that's all that's to it, and then it just goes and does it. Now it's up to your cluster manager that at that point to get the data where it needs to be, and then collect it all back to where it needs to be at the end of your driver script, and the machine starts running back with the results. So at the high level, that is how Spark works internally, and it's good to just understand again when we try to optimize the things later on in this course, when we talk about things like partitioning of data, like explicitly partitioning of data, and try to structure things in a way that reduces the amount of shuffles So keep that in mind. Alright, don't forget to subscribe to my channel, and if you have any concerns, questions, feedback, put it at the comments of the video. Thanks for watching and stay safe.